All right, let's begin by reviewing a one-step conversion. So a one-step conversion is what we've been doing up to this point. So we're going to be taking either grams or particles and then converting to moles or the other way around. So in this case, we're going to take 4 grams of PbNO3 and we want to determine how many moles we have. So we always start with what we're given. So we have 4.0 grams and we want to go to moles. So we're going to need the molar mass of this first. Well, we have, let's see, lead, Pb. Lead's molar mass is 207.2 grams per mole. Our 2 here is going to apply to the oxygen and the nitrogen. So let's see, we'll have 2 nitrogens. Each nitrogen has a molar mass of 14.01 grams per mole. And then we also have oxygen. Oxygen, we're going to have 6 total. Each oxygen has 16 grams per mole. So go ahead and do some multiplication, add everything up, and you get 331.22 grams per mole. All right, we don't need to do anything with sig figs here because this is just our molar mass. We're going to use this as part of our calculations. So the grams are going to go on the bottom, 331.22 grams for every 1 mole. And when we multiply this out, our grams will cancel. And our final answer will be, let's see, 0.01207. We have 2 significant figures, in our original number. That trailing 0 counts because it comes after the decimal. So we want 2 significant digits in our final answer. So going from left to right, those first 2 zeros don't count. Those are leading zeros. So the 1 and the 2 would be our first 2 significant digits. And we look at the third. So a 0, obviously we're going to leave this number as is. So our final answer will be 0.012. And the question was asking for moles. All right, so that's kind of where we left off. Those are one-step conversions. We're going to be looking at 2-step conversions today. All right, let's look at a 2-step problem. In the upper right-hand corner of the window, you will notice this. This is a map that, it's actually part of a larger map, but I'm going to go ahead and put a link to this in the description. This is a map that I give all of my students. This kind of gives you a good visual of how the conversions work. So in this question, it says we're going from grams, and we have molecules, and we're going to grams. Molecules, remember, are particles. So we're going to go first from particles to moles, and then we are going to go from moles to grams. So there are 2 steps, step number 1 and step number 2. Well, let's start with what we're given. We have 5.21 times 10 to the 23rd molecules. Now notice I wrote that all out. I didn't abbreviate it as moles. We don't want to confuse molecules and moles, so get in the habit of writing molecules out completely. So going from molecules to moles, we're going to use Avogadro's number, 6.02 times 10 to the 23rd molecules. And that's in 1 mole. So in 1 mole, we have 6.02 times 10 to the 23rd. So that's step number 1. Step number 2 is to go from moles to grams. So we need the molar mass of water. Well, the molar mass of water, we've done this one before. It's 18.02 grams. That's the molar mass. Okay, so let's look at where we left off. So far, we've canceled out our units of molecules, and now we're in units of moles. So our moles are going to go on the bottom. So for every 1 mole, we have 18.02 grams. All right, so our moles are going to cancel out because they are diagonal from each other. Now, when you enter this in your calculator, be careful. Use parentheses. You can do it as 1 over, or you can divide for the first conversion factor. For the second conversion factor, again, you can do it as 18.02 over 1, or you can just multiply it by the numerator. So when you multiply this all out, you get an answer of 15.5953. Our original number had 3 significant digits in it. So going from left to right, let's underline the first 3 significant digits and then look at the fourth, the 9. So is this going to be 15.5 or 15.6? Well, with the 9, we're going to round up to 15.6, and the units will be grams. That's a 2-step conversion. Let's do some more. In this next example, it says how many grams are in 3.7 times 10 to the 23rd molecules of calcium chloride. So again, we're starting at particles because we have molecules. Then we're going to go from particles to moles. That's step number 1. And then we want to end up with a mass, a grams. So we're going to go from moles to grams. That's going to be step number 2. All right, so we have 3.7 times 10 to the 23rd molecules. Again, don't abbreviate. We're going to use Avogadro's number, 6.02 times 10 to the 23rd molecules. And that's for every 1 mole. So that's our first step. So far, our units of molecules will cancel out. Now we're in moles. So moles are where we're at with units. So we've completed this first step. Our next step was we're going to go from moles to grams. And we're going to use the molar mass here. So for every 1 mole, what's the molar mass of calcium chloride? Well, I'm going to go ahead and give you the molar mass here. Molar mass is 40.08. All right, so for every 1 mole, we have 40.08 grams. Oops, accidentally erased there. Let me fix that. All right, 40.08 grams. All right, so our units of moles are going to cancel out. So when we do our multiplication here, again, use parentheses and be careful. I got 68.21029, and there are 2 significant figures here. So going from left to right, we underline the first 2 significant digits and then look at the third. So this will just be 68, and our units are going to be grams. All right, one final example. How many atoms are in 5.2 grams of aluminum? So this time we're starting at grams, going to moles, and then we're going to go from moles to particles. So we start with what we've got, or what we're given, sorry, 5.2 grams. If we look up aluminum on the periodic table, its mass is 26.98 grams for every 1 mole. So our units of grams will cancel out. So we've completed our first step. Our second step is to go from moles to particles. So anytime we go from moles to particles, we use Avogadro's number, 6.02 times 10 to the 23rd. It's asking for atoms, so I'll put atoms there. So our units of moles will cancel out. And when you multiply this all out, you get 1.16026 times 10 to the 23rd. Our original number had 2 significant figures. So going from left to right, if we underline the first 2 numbers and then look at the third, we will end up with 1.2 times 10 to the 23rd. and our units will be atoms. All right, those are two-step conversions.